Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Now, today we're going to be looking at Term 1 revision, Term 1 topic revision. So all the topics that we have done in grade 12, Term 1 syllabus, we are going to revise. We're going to have questions on them. Then we're going to be doing those questions. The topics that we have done, remember, we've done complex numbers. We have done analytical geometry. We have also done differential calculus. The lesson objective for today means that we need, by the end of this lesson, we must be able to work with complex numbers. We have done all the complex numbers in this term. Including the Argand diagram, the modulus, the argument, the polar form, rectangular form, and also solving two variables in complex numbers. We must be able to work with and apply the analytical geometry formulae. So all the formulae that we have done in analytical geometry, we must be able to apply them. We must be able to determine the equation of the tangent to a circle at a given point on a circle. So in other words, if I've got a equation of the straight line, because the tangent is a straight line, we need to be able to plot the graph of the ellipse, which must be in that form: x squared over a squared plus y squared over b squared, it's equals to 1. We also need to be able to solve the third degree polynomial that will help us in terms of drawing the sketches, finding the x-intercepts of the sketches. We need to also be able to determine the derivatives using the first principle. Also use the rules of differentiation to do derivation of those equations. We must be able to draw and interpret cubic functions and apply differentiation in real life problems. That is your application to differential calculus. Right, now let's look at the first one, which is the complex numbers. Remember, in complex numbers, what we've done, we need to know how to write this in rectangular form. We need to understand your Argand diagram. We need to understand the imaginary and the real axis. So in this case, you are given the voltage F, V in an alternative current circuit, which is represented by the Argand diagram. So you can see this is another Argand diagram where we have the imaginary axis, which is our y-axis in this case. The real axis, which will be the x-axis. Now we have got quadrant 1, we've got quadrant 2, and quadrant 3, and quadrant 4. So we can see this angle here, it's in quadrant number 3. So the diagram is in quadrant number 3, that voltage is in quadrant number 3. So we have a right angle triangle, which has got our R value there in a unit circle. Then that is 90 degrees. And then we have our angle here at 240 degrees. So in this case, you are given this voltage in this form. Right. We want to write down, you must use the Argand diagram to write the voltage in this form. So you're not given that form. You're only given the angle and the R. And that R, in complex numbers, we call it the modulus. We call it the modulus. In this case, we've got that angle here, and we call that angle an argument. So you must know these terms. By now, you must be knowing these terms. So now we have the modulus, and we've got the argument. We need to write it in that form. We know that the R will be the modulus, and the angle will be there. That theta there, which is an argument, is 240. So with this question, it's 1 mark. I'll give it only 1 mark. We just need to rewrite this one by just substituting the values. So we'll have your V will be equals to, my R in this case is going to be 2, which is the radius. Then we have the cos of, the angle there is 240 degrees. The I will remain. Then we have the sine of 240 degrees. So we only needed to write this in this form, and that's what they need. So the voltage there will be R into cos theta plus I multiplied by sine theta, of which the value of R there will be 2, and the value of theta there will be 240. The value of theta will be 240 degrees. So we write it in that form. The next question will say hence or otherwise. So in other words, we are having the word hence, meaning that use whatever you got there to express V in rectangular form. Remember, the rectangular form will be your Z will be equals to, or your V in this case, it will be A plus BI. This is in rectangular form, right? Remember, the other one was in polar form, so now this one will be in rectangular form. So rectangular form, it's A plus BI. So we need to write this one in the form A plus BI. So remember, we're having our V, it's equals to 2 into the cos of 240 degrees plus I times sine of 240 degrees. So what do we need to do here? We just need to get the angle of 240, the cos of 240 and the sine of 240. We can use a calculator, that is not a problem. We can go and get the cos of 240, go to your calculator and press cos 240 degrees, which will give me a negative half. So remember, it's in the third quadrant. The cos in the third quadrant is negative. So the answer there will be negative a half. Plus I multiply by. Now we go back to our calculator and then we say sine of 240 degrees. That will give us negative, because it's still also in that quadrant. So it will give us negative the square root of 3 over 2. Right? Then from there I can just put these brackets, square brackets like that. So now I can then multiply the 2 inside the bracket. So I'm going to have the 2 and that 2 cancels out. So I'm going to have negative 1. So remember, the 2 is a positive, and the negative times this positive will give us a negative times that positive outside 2. So which will give me a negative. So that will be negative 2, and that 2 cancels out. So therefore we're going to have what is left, there will be square root of 3. Remember, we need to multiply that by I. So this is in rectangular form. So a rectangular form, it's in that form A plus BI. You can see the value of A there will be negative 1, and the value of B there will be square root of 3. So this is B. And then we have our I, right? So this is in that form, which is a rectangular form. So you must know the difference between the rectangular form and the polar form. This one will be in polar form, that one will be in rectangular form. So we must know those two. All right. Now, the next question will be basically the type of questions that, so these questions, we're taking them from past papers. These are type of questions that you get in your exam papers. So determine the numerical values of m and n. So we've got m, n, if you are given that 3 plus 5i plus m minus ni equals to 6 minus 2i. So in this case, the simultaneous equation, simultaneous but in one line. So remember, in the simultaneous equation, mostly when we do simultaneous equation, we find that we do two equations, but in this one, we're having only one equation. Now, how do we do this? Remember, we know that when we want to find the value of that, if I've got, for instance, A plus BI equals to M plus NI, for instance. So the real part here will be equals to the real part on the other side. And the imaginary part here will be the same as the imaginary part on the other side. So if I've got something like this, then I can be able to work out what will be my real part, the value of the real part and the value of the imaginary part. So in this case, I can see here, so the easy way to do this is to always make sure that you know which one is the real part, which one is the imaginary part. So this one is the real part. The other real part will be that. So the real parts do not have an I. So therefore, that will be the real part. Remember, if it's I squared, if I get something which is I squared, then I know I squared can be changed to a negative 1. And this side here, I can see the equal sign. I can see there's another real part here. So these ones are real parts. So therefore, the ones with an I with its sign are going to be the imaginary part. This one is an imaginary part. That one here is an imaginary part. Remember, we take it with a sign. So if I want to equate now, therefore I'll say the real part and the real part this side will be added together. So it's 3 plus m. So I'm going to write 3 plus m. On the other side of the equal sign, which one is going to be the real part? It's going to be 6. So I'll have a 6 here. So in this case, now it's much easier for me to solve the other part. So now, on the other side, I want to write down the imaginary part. So in this case, the imaginary part there is plus 5i, but I'm not going to write the I. So I'm just going to write the numbers that are next to the I. Or you can write them, but at the end of the day, all the i's will cancel out. So now, in this case, there I'm going to have minus. So can you see the 5i there minus the ni? So I'm going to subtract the n because there's a minus in there. Then there's an equal sign. Then I'll have the minus 2. So I'll have minus 2. So remember, if I write an I on all of them, the i's are going to fall off, all of them. So now I can then solve this. I have this equation here and that equation here, which are simple linear equations that every one of you must be able to solve. So here the m will be equals to, then I'm going to have a 6 minus a 3. Then the m value is going to be 3. Right, easy. So now I got the values of m, the numerical value of m is 3. Then on the other side, I do not have any m. If I had an m, I'll replace that m by the 3 that I got. So in this case, I do not have. So I can just solve for n in this linear equation. So minus n equals to negative 2. Then I'm going to then subtract a 5. Then I'm going to have n is equals to negative n equals to negative 7. Then I divide by negative 1, so the n will be equals to positive 7. So I've solved for m and n simultaneously. So you can see that we are able to solve m and n in one variable, I mean the two variables, in one equation, and we get m equals to 3 and n equals to 7. These are easy questions that we must be able to do. We'll see the other one where we have two variables in one equation here, then we need to also be able to do this. Okay, right. So the complex numbers are quite very easy. We must get full marks in this section. Now let's look at a different one here. In this case, now you're given the angles. You can see, given the complex number, z, you can see that the angles now are given 3 over 4 pi. What do you know about that? So they're now given as radians. They're now given as radians. We can then change them to degrees. And we must know how to change from radians to degrees and back again from degrees to radians. So the first question says, write down the modulus. So all these terms, you must know these terms. The modulus. So they're just saying write down. So here we're not calculating anything. Mostly when we get these questions, the biggest challenge here is what is being asked. But sometimes you find that you know the answer, but you don't understand how the question is asked. So you must read the question and reread it again. Write down. So we are not calculating anything. We're just looking at what is given here and write down what we can see as a modulus in there. We've got too many numbers there. We've got square root of 2, we've got 3 over 4 pi, we've got 3 over 4 pi. Write down. the modulus of z. So what do you know about the modulus? Is the value of r. Okay, so the value of r is that square root of 2. So how do I write down the modulus? The modulus there is nothing else but the square root of 2. I don't need to calculate anything. I'm just writing down. So the modulus of that will be square root of 2. Then the next question will say, write down the argument of z in degrees. So in this case here, you are given it in radians. So remember, this one is an argument. That one is the radius, is the modulus. So the arguments now are written in radians. So you must change it to degrees. So write down the argument of z in degrees. So how do I change 3 over 4 pi to degrees? So how do I do that? So I'll take 3 over 4 pi. So for me to write it in degrees, then I must multiply this by. We've done this. So it should be 180 degrees all over pi. So if I want to change it degrees to radians, so it will be pi over 180 degrees. So in this case, I want to eliminate the pi, because remember there is 3 pi over 4, which is the same thing. Then I want to eliminate that. Then I go to my calculator and I say 3 over 4 multiplied by 180 degrees. Remember, I no longer have pi there. So the angle that I'm going to get now, I'm getting an angle, and that angle is now in degrees, which is 135 degrees. Which means that if I had to draw my Argand diagram, so which means that that angle will be in the second quadrant. So that will be in the second quadrant, the 135 degrees. Okay, all right. So now, in the second quadrant, I know that point here. So if that point is A and B, obviously I know that the X will be negative and that will be positive. The B will be positive. So when I express this in rectangular form, then I must also see that my B must be a positive number, my A must be a negative number. If that is not the case, then I know immediately that there's something wrong that I've done somewhere. All right, now let's get to that. So in this case, they say express Z in rectangular form. Remember rectangular form? It's A plus BI. So meaning that if it's in the second quadrant, the A will be positive. The A will be negative, the B will be positive. So let's see. So the Z will be equals to square root of 2 into cos of 135 degrees plus I multiplied by the sine of 135 degrees. Okay, so in this case, nobody said you must not use a calculator. There's no way that they say don't use a calculator. So we go straight to our calculator. We calculate the cos of 135. I prefer writing this as a fraction than as decimals. So therefore, we go to cos of 135. Then as a fraction, then I get 1 minus 1 over square root of 2 plus I multiply by the sine of 135. So I go to the calculator, sine of 135, and I get 1 over square root of 2, close bracket. Then from there, my answer will be, I can see if I multiply square root of 2, this is over 1. Multiplied by that, my answer is going to be negative 1. If I multiply square root of 2 by that, my answer is going to be positive 1, because there is a positive value. So it's positive 1, but there's an I. So I can write this one, it's negative 1 plus I. I know that the coefficient of that will be 1. Can you see now? In the second quadrant, now I know the A value is negative and the y value there is positive. So I'm right because the a value is negative and the y value there is positive. Then I definitely know that that answer is correct, because that will be in the second part. So you can see when you're doing this type of questions, if you put this on an Argand diagram, you are able to can see that this one, remember, it's an imaginary axis. This one is the real axis. You're able to can see whether your answers are correct or not. So once you get the angle and locate the angle in the correct quadrant, you'll be able to can see that, oh, now I can see that that one will be in the second quadrant. It's less than 180 degrees and it's more than 90 degrees. So it must be in the second quadrant. In the second quadrant, the A value will be negative, Y value will be positive. If I get something strange here, where the y is negative and the a, then I know, no, there's something wrong that I've done somewhere with my calculations. I must just go back and fix that. Okay. All right. Here's another question there. Solve for x and y. So you can see in this case now, you can see that we need the value of x and the value of y. One equation is given. We need to equate your real and your imaginary. So now, first of all, first thing that you need to do, you must make sure that you don't have any I squared here. Secondly, you must make sure that you don't have any bracket. Thirdly, you must know that you must not have any quotient where they divide. When they divide, make sure that you use your conjugate. If you see the brackets, multiply out the brackets. Okay, so in this case now I see that this is a simple one because then everything is there. So I can just, this one is my real, this one is my real part, this one is my imaginary part, that's my imaginary part, that's my real part, this is my imaginary part. Okay, so now I can then be able to can group these things together. Then I'll say my real in my left hand side will be the x value minus the y value. That is all. I think I've got those two, right? On the right hand side, I've got my real. This side is going to be my 2. So this is on my real side. On my imaginary, let me just do this. On my imaginary, on the other side, I have my imaginary, I have x. Remember, I don't take the I. I've got the y plus y. On the other side, I'm having a negative 4. Right. So in this case here, you can see I've got x and y on the real, I've got x and y on the imaginary. So now I cannot solve for x and y in this case here. So I must use both. So to use both, it's either I can use the elimination method that we have done in grade 10, or I can use the substitution method that we have done in grade 11. So any of those two methods will work. So in this case, but I can see the elimination method will be quite easy. So elimination, if I've got equation number 1 and equation number 2 here, with the elimination, then I can just take that equation, put it underneath this one. So I'll have x minus y, it's equals to 2. So I'm just subtracting the 2. So therefore I subtract this. So what do I get now? I'll get x minus x is 0. Y minus minus 2y, y minus minus y. So there will be a positive, so I'll get 2y. Then I'll say minus 4 minus plus 2. So that will give us negative 6. So my y value will be equals to negative 3. All right. Now for y is negative 3, how am I going to get the value of x? So I'm going to substitute it there. So I'll have your x minus into minus 3 equals to 2 to get the x value. So therefore I'm going to have x plus 3, it's equals to 2. And the x value is going to be 2 minus 3, and x will be equals to negative 1. So my two values, x value is this, My y value is that. Alternatively, we can use this Martinez equation. In this Martinez equation, obviously, I have equation 1. I can make equation 3 from this. Then I just substitute into the third equation. Okay, so I have equation 1. So I can make x the subject of the formula. I'll have 2 minus y. This is all. I'll have 2 minus 1, which will be equation number 3. Then I can then substitute this one into that equation here, into this equation, which I'm going to have 2 minus y on the 2. So I'm going to substitute into this equation. So I'm going to have 2 minus y. Let's see which equation am I substituting? So it's x minus 2. So there will be 2 plus y, sorry. So I'm going to have 2 plus y equals to negative 4. Then I'll have 2y, it's equals to negative 6. If I transpose that to that side, then I'll have my y will be equals to negative 3, which is the same as that one. Then I can just substitute this one here to get to x value equals to 2 minus 3, which will give me x equals to negative 1. So I can get that answer. So you can either use any of those methods, they'll still give you the same answer. Okay. All right, so complex numbers are quite very easy. We must be able to navigate ourselves through complex numbers and do very well in this type of questions. About 15 marks in an exam. So we must be able to practice and get that 15 marks. All right, now let's go to the next topic, which is analytical geometry, which is also grade 12 analytical geometry is one of the easiest. Even the grade 11 one is very, very easy because the formula are given. So we just need to navigate through the formula. We need to understand how to use a formula. We need to attach a correct formula into the correct question. So how you can practice it is that you take analytical geometry questions and without working on them, just attach formula where they're needed. Once we are able to attach formula where they're needed, it will be easy for us to pass that. Then you just substitute and get the answer. Substitute and get the answer. In activity 3, in the diagram, O is the center of the circle with that equation. You see, the equation is given. Obviously, I know that this equation there, this thing here, it's r squared. Point A is given as 1 and P, that's point A. And point B lie on the circumference of the circle. Very important that we know that point B is also on the circle. AC is the tangent, so that whole line here touches that point A, the circle at only one point. So it is the tangent. Write down the length. See, once they say write down the length of the radius, there's not much that you must do. Just go to the radius, which is r squared in this case. So they want the length of the radius. Remember, r squared is not going to be the length. So r squared is square root of 17. So r squared is 17. Sorry, r squared is 17. Now, how do I get the value of r? Is the square root of 17, which is approximately, I think, 4, if I'm not mistaken, should be 4, square root of 17 should be 4,12. Which means the length of the radius, the length of this line from here to there, or from there to there, it's square root of 17. Right. Okay, now, in the next question, they'll ask you now to show. We know with this question of showing, the answer is already given. Those are some of the challenging questions that, most learners find this very challenging. Because once the answer is given and then you work it out and then you don't get to this p equals to -4, and you get a bit discouraged, but don't. Because if you do it correctly and check all your calculations, you must be able to come to the answer. So the P is on the A, and that A is on the circle and also on the straight line. Do I know the equation of the straight line? No, I don't. Remember that P is the Y value. The X value is given. Do I know what is the length of the radius? Yes, remember that is the length. Okay, right. So now for me to do that, the equation that is given is a circle. The straight line is not. If the straight line was given, I will substitute into the straight line. But which equation is given now? Is the equation of the circle. So I'm given x squared plus y squared equals to 17. Right. So now I've got the x value. I've got I don't have the y value. The y value is p. It's given. I mean, it's there. P equals to -4. But I can't substitute with that value because this is what I need. I need to show. And that's why we have a problem, because we use the information that is given, like show that, the information that we need to get, and then we use it in our sum, and that it's not correct. You can come here and substitute this one by 1, substitute this one by -4. I mean, you're going to get 17, obviously, because that answer is given. But we want you to show how do you get to P equals to -4. That's exactly what we need. So in this case, the X value, it's 1. The Y value, it's P, and this is 17. So then now we can solve for P. So that will be P squared. The 1 squared is 1. Transpose it, 17 minus 1, which is 16. So this is P squared. So what do I need? I need the value of P. So I need the square root of this. So square root of 16 plus or minus. So the P value will be -4, or the other one will be 4, +4. But what do I know about the P in the fourth quadrant? Then the P in the fourth quadrant is negative. So therefore, my P will be equals to -4. This is in the fourth quadrant. I know that in the fourth quadrant, the Y value is going to be negative. That is why my P will be -4. So I've shown that P is -4. I didn't use -4. You can't use what you need to show. So if they say prove that P is -4, you must have some steps to show how we get to -4. And this is a challenge to most of the learners, because what you do is you use the P equals to -4. And then from there you get the left-hand side to be equal to the right-hand side. You have not proved it. You have not shown us how to get to -4. So it's very, very important that in these questions that say show, you must work it out until you get to the answer that has been given. I know some of you will do miracles there. I don't know. You just do a substitute, and from there you get something else, and then you say, therefore, P is negative. No, you can't do that. Please make sure that you follow the correct steps in doing that. If this straight line, equation of the straight line was given, I was going to substitute this X value and the Y value on the equation of the straight line. Then I'll get to my value there, my value of P, which is in the fourth quadrant. Okay. Right. And it says now, hence, already now I know that A value there is 1 and -4. Now they say, hence, write down the coordinates of B if AB. You see that line AB? So in grade 11, you have done this theorem. The line from the center of the circle perpendicular to the chord bisects the chord. Okay. Obviously, if it bisects, means that the distance from here to there must be the same as the distance from here to there. So I know the distance from here to there because it's from here to here, which is going to be 1. So meaning that the distance from here to there must also be 1. The distance, I'm talking distance now. So which means that if this is 1, the B coordinate is going to be -1. X value will be -1 because it's on my. Obviously, this line is perpendicular to that line, which makes that line to be parallel to this. If these two lines are parallel, which means that my P value will still be the same at that point. At that point, my P value will be -4. So the coordinates of B will be B is -1 and -4, because at that point here, it's -4, because those lines are parallel. Okay, so the parallel, that point here and that point there. This is 90 degrees, that's 90 degrees, so the two lines are parallel. That is why there they wrote A if AB is perpendicular to that. So if it's perpendicular, it means that the line from the center of the circle perpendicular to that chord AB bisects this line. So if the line is bisected, means that now the distance between y-axis and the A and the distance between the y-axis and the B will be the same. So it's 1 unit to that, 1 unit to that, so therefore that point will be -1. So please, we must read the question and understand it and make notes on our sketch so that we understand what we're doing. Okay. So we're just writing down, there's nothing to calculate in there. So we're just writing that question down. Okay, 3.1.4, determine the equation of the tangent. Now we know this point here is 1 and -4. We need the equation of this line here. That line is it's a straight line, so the equation must be given as y equals to mx plus c. Right. So there they were supposed to say in the form y equals to mx plus c. If they did not say it, so you can put it in any form, because they just said write down the equation of that. But in this case, let's also practice to write it in the form y equals to mx plus c. There are two ways of doing it. The first method will be drawing the radius. We know that that radius is perpendicular to the tangent. So that radius from the center of the circle to the point here, it's perpendicular to that. So first I can get the gradient of the perpendicular line. That is the gradient of the radius. So I can go the gradient of the radius. This is coordinate 0, 0. So I can say 0 minus -4, which is going to be 0, -4, over 0 minus -1. So the answer there is going to be 4 over -1. So the gradient of that will be -4. So now I need the gradient of the, remember, and now I need the gradient of the tangent. So remember, the gradient of the tangent will be, so I take the -4 over 1, then I turn it upside down, then I change the sign. So if it's 4 over 1, then I'll make it 1 over 4. This one was negative, so this one will be positive. From there, then I can have y minus. So remember, I've got a point here of A. So it's y minus into -4 equals to the gradient now, it's 1 over 4 into x minus 1. Okay, so then I can have y plus 4 equals to 1 over 4x minus 1 over 4. Then I can rewrite that as 1 over 4x minus 1 over 4 minus 4. Then if I add these two, I'll get 1 over 4x minus 17 over 4. So the equation is in the form y equals to mx plus c. So the equation of that, can you see the gradient is it's increasing. So therefore, that's why we have a positive gradient increasing from my left to the right. Then I know, oh, that question should be correct, right? The other method will be, this formula is not there in the formula sheet, remember? So you must just know it, right? So already I know the radius. So therefore, the x1, I'm going to use these points here. X is 1. The y value is -4. The r squared is 17. Then I'll have x minus 4y equals to 17. Then I'll have minus 4y equals to minus x plus 17. Then I divide everything there by 4, -4. I'll get 1 over 4x, then minus 17 over 4, which is the same as that one. So it's either I can use that method of getting the gradient of the radius and the gradient of the tangent. Then from there, I can use the formula y equals to y minus y1 equals to m into x minus x1. Or I can use that formula here, which is not on the formula sheet. Must practice it and then know it. And that takes you straight to the equation of the straight line. Okay. All right. The ellipse, as I said, this is the easiest question in the question paper, in paper 2. Easiest question in paper 2. The question will come in this way. X squared over 25 plus y squared over 4 equals to 1. So that part here must always be equals to 1. So what I do is, because this is x squared, I need the square root of that now. So the square root of 25 is 5. Remember, it's on the x-axis. So I go to the x-axis and I have a 5 here and a minus 5. Remember, it's plus minus the square root of 25. Then I go to the 4, it's on the y, square root of 4 is 2. So it will be plus minus 2. So plus 2 is there, minus 2 is there. Just take your pen, don't use a ruler, connect these points, connect that point, connect that point, and voila, you have your ellipse. That's three marks. Because 1 mark will go for the x-intercept, 1 mark for the y-intercept, 1 mark for the shape. Easy, easy, easy 3 marks. Every one of us must be able to can get those 3 marks. These are easy 3 marks. All right. Okay, we're going to take a 2 minutes break and we'll be back. Right, welcome back. Now let's continue with the analytical geometry, activity number 4. Same thing here. Only difference here is that we can see here, we don't know whether that line EF is a tangent, but they say it's perpendicular to the to the x-axis. We've got a point G, the point G is 6 and negative 8. That is also on the 4th quadrant. Nice. So O is the center of the circle. FH is the tangent to that. So we are not told about EF. So the circle cuts the x-axis at point E. H is the point on the x-axis. EF is perpendicular to the x-axis. Determine the equation of the circle. So we know that the equation of the circle can be written as x squared plus y squared equals to r squared. So I look at all those points that have been given, point E, point G, point H, point F. Which points are on the circle? We see point F, it's on the circle. Point E is on the circle. Point F is not on the circle. Point G is on the circle. Point F is not on the circle. The only point that has got values is point G. So I'm going to use point G here, which is 6 and negative 8. So I'm going to substitute now. Remember, for me to get the equation of the circle, I need the r squared. So now I'll say x squared, the x value is going to be 6 squared, put it inside the bracket, plus the y squared is negative 8 squared, then r squared, I don't know. Therefore, r squared will be equals to 36 plus 64, that will give us 100. So r squared is 100. So which means my equation of the circle will be x squared plus y squared equals to r squared. In this case, it will be 100. Please don't get the value of r. Because once you get the value of r, then you come back and write down the r squared as 10. And that is very much incorrect. So the equation of the circle must be with an r squared, not with an r. Okay, unless if they say, determine the radius of the circle. So if they say, determine the radius of the circle, then my r squared becomes 100 and r will be square root of 100, which is 10. In this case, they did not ask that. Right. Okay. Let's move on. 4.2, determine the equation of the tangent FH. So FH, I'm told, is a tangent. The point here is 6 and negative 8 for G. The easier method is the one with the formula that I gave you. So I'll use that easier method now, which is x multiplied by x1 plus y multiplied by y1 equals to r squared. Isn't that I know what r squared is? Then I'll get x multiplied by my x1 is 6, my y1 is negative 8, my r squared is 100. Then I must make it y the subject of the formula, but first I'll have 6x minus 8y equals to 100. Negative 8y equals to negative 6x plus 100. So now this is in the form, I must put in the form y equals 2. So divide everything by negative 8, everything by negative 8. Then I'll get y equals to 3 over 4 x minus 100 over that. So 4 goes there 25 times and 4 goes there 2 times. So the answer will be 3 over 4x minus 25 over 2. My gradient is positive. This is an increasing graph, no problem. See, if that one was a decreasing function, my gradient will be negative. So that will be my equation of that graph. An alternative method will be to go first to get the gradient of that line, then get the gradient of that line, use the formula y minus y1 equals to m into x minus x1. So you have got a choice of those two methods. So if you want to use this method, that's still fine, you get full marks. You want to use the other method of getting the gradient because maybe you forgot how to write down that formula. You go the easier way of getting the gradient of this line, gradient of that line, use the formula that is in the formula sheet, then you get the same answer. Okay. All right. 4.3 says now we must get the coordinates of E, point E. Point E is on the graph of this outside on the circle graph. Yeah. So now you have this line here. What do you call that line? It's a radius. Because it's from the center of the circle to the circumference of the circle. That one is also a radius. That one is also a radius. That one is also a radius. So all those points. But this one here is on the x-axis, which means the value that I get, the E point here, I don't know what is x, but I know what is y. The y value there will be 0. So I can either go and substitute or I can use the radius. I can go and substitute or use the radius. But I prefer to use the radius. The radius, by the way, the radius there squared will be 100. And the radius will be square root of 100, which is 10. So from here to there, it's 10. But the point cannot be 10 because this is on the left of 0. So the point there will be negative 10. So in other words, my coordinates of E will be negative 10 and 0. Okay. Or I can just go and substitute the value for x. I know what is the value of y. So I can just go and substitute. Take my equation x squared plus y squared equals to r squared, which is 100. Then the x value I don't know. The y value I know it's 0. And then equals to 100. Then I'll get x squared equals to 100. And I can get x equals to plus minus the square root of 100. I'll get x equals to 10 or negative 10. But at point E, I know it's on my left-hand side of 0. Therefore, my E coordinate will be negative 10 and 0. See? So I can either go this route or I can just get the value of the radius. That's an easy one, easy way to do it. Get the radius. But in this case, remember on that one that we got, the previous one that we got, that point here, we need one of the values to get the other one. So if I'm given this value and that one is not given, I can be able to get it. But if I'm given two values here, I will not be able to do it. Okay, right. Unless I can be able to get the radius. Okay. Now 4.4 is a bit tricky here. We need to determine whether these two lines are equal. Obviously here they're asking you about the distance. Okay, so line EF and line EG. So EG will be from here to there. So we want to find out if the length of this line and the length of those lines are equal. So for me, E point, I've got the E point. The E point is negative 10 and 0. That point here, I do not have. That length I can be able to get because I've got the 2 points. Now my problem will be here to get EF because I really need to get EF. But what do I know about EF? I know that the x value at F is minus 10. but I don't know what is my y value. For me to can be able to can get it. If I get my y value, I know the distance of that line. But how am I going to get my f value? Remember, I've got the equation of that line, no problem. This point here is on this line. So I can be able to can get it. Wow, very tricky. Now, let me get EF first, because that's an easier. I've got the equation of y equals to 3 over 4x minus 25 over 2. Remember the x value I know, I don't know what is the y value of that point here. So for me to get a y value, I must substitute that x value into this line. You see, I'm substituting on the equation of the line. That word hence, meaning I'm using what I got there previously to do that. So I'll go y is equals to 3 over 4 multiplied by negative 10 minus 25 over 2. Now the length of that will be equals to, I go to my calculator, 3 over 4 multiplied by negative 10 and then minus 25 over 2. The answer that I got there is negative 20. But remember this point here, now this point is negative 20. Negative 20. If that point is negative 20, what am I going to do now here? I've got negative 20 here. So meaning that here it's negative 20. The length of that line here is negative 20. There is 20. Can never be negative 20. So the length of EF will be 20 units, positive. Remember, there is the length. We are not talking the coordinates. It's the length. Now, if I've got the length of that, I now need the length of EG. So the length of EG will be the square root of, now I can use the distance formula for that. No problem, I've got all the points here. So I'll go 6 minus into minus 10 all squared plus negative 8 minus 0 squared. Right. So therefore, I can immediately use a calculator there. Because there I can see I've got 6 plus that, it will be 16 squared minus to negative 8 squared. So if I use my calculator there, I think I get 656. Right? So from there, I can then get the square root of that. I think it will be decimal. I think it will be 25.61. You can assist me there with a calculator. I think it's 25.61, which is EG. So you see, the equation needs me to determine whether these two lines, the lengths of those lines will be equal. In this case, I can see they are not equal. Which one is bigger? EG is longer than EF. So I can just say the length of EG is greater than the length of EF. Or I can just say the length of EF is smaller than the length of EG. Okay, put it that way. Because I can see this is 25.61 and there's 20 units. The tricky part there is to get to the length of EF. That length is fine, we can get it distance formula, but the length of EF is going to be a bit of a problem. So can you see that if we did not get the equation of that line, I would not be able to can get. If I didn't get the coordinates of E, I will not be able to can get the length of that line. Okay, so it's very, very important that those questions, those leading questions, we must be able to can get them, because the last but one question sometimes need you to go back to that information and try to get that information correct. Okay. All right. Now, the next activity there, it's activity 5. How do we solve a third-degree polynomial? This question helps you to calculate, to determine the x-intercept of a cubic graph. if I'm unable to can solve this type of questions, I'll have problems in terms of getting the x-intercepts of the graph. And the x-intercepts of the graph are very crucial in drawing a correct a cubic function, the cubic graph. So in this case here, if I can just say solve this x, it's a bit of a challenge in here, because then it means that I must try values, and and then from there I must get one value which is going to be a factor. If I can get one value which is a factor, I must then use, there are three methods, if I'm not wrong, on how to use one factor to get to the other factors. The one method that I'm going to use now, I know most of teachers are doing the synthetic method, and there's a long division method, and the other method whereby they're doing by inspection. But let's move with this one. How do I get one factor? So first, I must try values. Let me try x minus 1. Sometimes when you try the first one, then it's correct. You get 0. So if I try that, so I'm going to substitute the value of x by positive 1. Then I'll have minus 3 into 1, minus 13 into 1, plus 15. If I get a 0, then I'm fine. I've got 1 minus 3 minus 13 plus 15. Oh, I'm lucky. 15 plus 1, it's 16. Minus 3 minus 13, it's negative 16, and then I get a 0. Oh, therefore, x minus 1 is a factor. Well, I was very lucky with this one. Okay. It doesn't give you 0, so it means that I'm going to try another one. In this case, I'm first going to do it by inspection. So I know that this one is one factor. Now, how am I going to get the other factors? Listen very carefully. For me to get x cubed, I need to multiply the x here by x squared. For me to get plus 15, I must multiply this minus 1 by negative 15. Right, I'm done with it, with those two. So I can, if I multiply this, I get this one. If I multiply that one, I got. Now I need those other two. Right, so now, for me to get x squared, for me to get minus 3, so if I multiply this by that, I'm going to get negative x squared. But here I've got negative 3x squared. So from negative 1x squared, I need minus 2x squared, because that multiplied by that will give me negative 2x squared. So I can be able to get minus 3x squared. And once I've done that, this one will come up. Okay, so meaning that my x minus 1, that can be factorized, minus 5 and plus 3 equals to 0. Then x will be 1, or x will be 5, or x will be negative 3. Right. Okay, so this is by inspection. You can use any other method. If, for instance, if I go to synthetic, you've got a 1 here, which is a factor. Then I must write down the coefficient of that, which is going to be 1, 3, negative 3, sorry, negative 13, plus 15. All right, let me just put this there. Right? So remember there, I'm now going to add. I don't subtract in that, I add. Okay. So now the 1 I'll carry here. Then 1 times 1 will give us a positive 1 here. 1 times that 1 will give us a positive 1. Then from there, if I add this, so remember it's minus 3 plus 1. So which is going to give us minus 2. Then from there, I'm going to then multiply that one. I'm going to get a negative 2. So that negative 2 times that. So if I add those two, I'm going to get negative 15. If I add minus 13 and minus 2. Then from there, if I multiply, then I'm going to get negative 15. And the last part here is going to give us a 0. Then I'm going to have my x minus 1, which is a factor. Then I'm going to have that, so it's x minus, the other one will be second degree. Okay, and then, sorry, right? And that one will be negative 15. Then from there equals to 0. Then I can have x minus 1, x minus 5, x plus 3 equals to 0. And then those answers there. Okay, so synthetic method also, you can use it. You can also use your inspection. You can use all these methods. There are 3 methods that you can use. You can also use your calculator. You can go to your calculator. I know you love your calculators. You go to your calculator and then you can input the equation, that whole equation, and check maybe between 6 and minus 6. Check all the factors that are giving you 0. Write them down. You get full marks. You might be lucky. If you get 2 of them, it's easier to get the third one. Say you get this one and that one, it's easier to get that one. If you get this one and that one, it's easier to get that. So you can still use all these methods. You have done this method. Practice all of them so that you don't get stuck in an exam. Right, now, in differential calculus, the first question in differential calculus mostly will be determining the first principles. Using the first principle to determine f prime x, first principle. So in the first principle, quite very easy, this one. This one, it's 3, 4, or 5 marks, depending on the examiner there. So here, f of x, you must write the correct formula. We are still having learners who are writing wrong formula. When the formula is there in the formula sheet, you go and copy it as it is. Right. Then from there, substitute the lim of 3. Where I see an x, I substitute it by x plus h. Then I don't forget the plus 2. Right? Minus. When you subtract, you're subtracting f of x as it is. So it's 3x plus 2. Then you put your h in there when h approaches 0. Then you clean up. Let's clean up. So we have 3x plus 3h plus 2 minus 3x minus 2. The mistakes that we always do is just to multiply this one by that, and then we forget to multiply it by plus 2. Please, please, please check that. All over h when h is approaching 0. Then we're going to have the lim of this one and that one, it's 0. This one and that one is 0. Then we're left with 3h over h when h approaches 0. That those two there, they divide each other there, then the answer there is going to be 3. Right. Okay. So first principle, we must all know how to do it. The rules, very easy to work with the rules. Once you know your exponents, very easy to, once you know your algebra, it's very, very easy to do this. I cannot get dy over dx with this. So first I must write it without a square root. So I'll have y. You see now I'm not differentiating. I'm still writing it like that, but I'm just changing that to x to the power of half. I cannot derive this part and then leave out that one. So then I know it is now properly written. Then I can write dy over dx. 2 times 1, it's 2. Subtract 1, we get 1. Half times 1, it's negative half times negative times 1. So therefore the x, subtract 1 there, I'm going to have negative 1 over 2. Then I can leave it like that. Okay. In the second one, I cannot derive the top. I can see that the top part here can be factorized. So meaning that I must first factorize the top part. So I must first have x minus 1 and x plus 1, all divided by x plus 1. I can put this in brackets nicely, so that I can see that that and that cancels out. Okay? They divide each other there. Then I'm going to have the x of x minus 1. That is what is left. Then the derivative of that, I just write equal sign. Don't write this again. So the answer J is 1. Because 1 times 1 is 1. Derivative of a constant is 0. So the answer is 1. Please do not write this there. Okay. Right. So then you write down your final answer like that. All right. This is another question that is asked every year, but they changed it a bit sometimes. But if you understand how to approach this question, you'll be able to do all of those questions that they ask. The equation of the tangent with a curve defined by this at a point x equals to 1. In other words, if we have a graph of 5x squared minus 3x, it will be a graph like this where the x value is going to be at 0 and the other one will be 3 over 5 positive. So it will be a graph like this, right? So in other words, we want the tangent at x equals to 1. So maybe somewhere there, the point 1, also somewhere there, the point 1, so the graph, the tangent of the graph at point 1, somewhere. So we need the equation of the tangent. So what do we know about this? That if I derive this, I'll get the gradient of the straight line and I substitute by that point. So for me to get the gradient, I must first derive this. Remember, derivation is gradient. So for me to get the gradient of that line, I must derive it. So let me first get the gradient of the graph. First, I know that that point there will be negative, it will be 1. I don't know what is the y value. For me to get the y value, I must substitute the value of x by 1. So I'll say g into 1, it's 5 into 1 squared minus 3 into 1. Then the answer that I'm going to get is 5 minus 3, which is 2. So meaning that the point there will be 1 and 2. So to find the gradient, I must first derive gradient at a point. That's what we're talking about. So if I derive this, I'll get 10x minus 3. So if I need the gradient, I must then substitute that by 1. So I'll get 10 into 1 minus 3, which is going to give us 7. So my gradient for this line is 7. I've got a gradient, which is 7, and I've got a point. To get the equation of the straight line, it's quite easy now. So I can go y minus y1, which is going to be 2, into gradient into x minus 1. So gradient and a point can give me equation of the straight line. That's how easy that will be. So now I'll have y, it's equals to, sorry, this is nothing. So it's y equals to 7x minus 7 plus 2. So my equation will be 7x minus 5, which will be an increasing function. So it will be at 1. So that will be, see, I've drawn a picture, and that picture looks like my answer. It's close to what is depicted on the picture there. Okay. All right. All right. In the next one is the graphs. Also very quite easy, straightforward. I mean, with the graphs, if the graph is given, how do you interpret the graph? The equation is given like this. Yeah, then I need the B and the C and the D. But we are given a point here, which is a turning point, and it's also a x-intercept. Nice. If I'm given that point as a turning point and as an x-intercept, I now got two things here. Turning point, x-intercept. There I've got a 0.5 and 0 there. So they say, this is the equation. Show us how to get that equation. Easy. I already have vectors. The x-intercepts are there. So what should I do? I must first write it down, my values. So it's x. If it's -1 there, it will be x plus 1. And we have another one here, 5 and 0. So it's x minus 5 because it's plus 5. Then I know that here I've got two things, turning point and an x-intercept. So what I need to do is that to put a square on the one where we have two things. So if I work out this, x plus 1 all squared will give me x squared plus 2x plus 1 multiplied by x minus 5. So if I multiply out these two brackets, I'll have x cubed. This one times that will give me minus 5x squared. This one by that will give me plus 2x squared. This one by that will give me negative 10x. And then 1 times that will give us plus 1x. Then we've got negative 5. So if I clean up that, I'll get x cubed minus 3x squared minus 9x minus 5. And that is what is given in there. So if you see that, you know it's squared. So that one is one of them. So I've got my equation here, which is correct. Straightforward and very, very, very easy. So the equation is given. I know what is my B. I know what is my C. I know what is my D. The other way of asking it, they will say, show that the value of B is -3, the value of C is -9, and the value of D is -5. Then, or they can say, show that that is the equation. In this case, they wanted you to multiply out. Okay. Right. Obviously, if there was an A here, what I'll do is they will give you another point somewhere, or somewhere there, or somewhere there. So that then you substitute the value of x and y to get the value of A. Remember, the A, you cannot see it on the graph, okay? Right, you just know that it's the shape of the graph, so it must be calculated. Okay, write down the coordinates of B. Already I've got the equation. I know that the B value, the x value is 0, and the y value will be the -5. Remember the equation there? It was h of x is equals to x cubed minus 3x squared minus 9x minus 5. So if I put the value of y of x to be 0 there, the y value will be -5. So the coordinates of B will be the 0 for the x and -5 for the y. Okay. The coordinates of C, this is the turning point. One of the turning point is given. Then I need the coordinates of C. So how do I get the coordinates of C? I need to derive this. But I already know that I have one of the coordinates. But I must still derive. So if I derive h at x, I'll get 3x squared. Remember here, the gradient is 0. So when you derive, you're getting the gradient. So the gradient is 0. So I'll have -6x. I'll have -9. Then I'll have that, because it's gradient, it must be 0. So I'm going to divide this by 3. So I'll get x squared minus 2x minus 3 equals to 0. Why? Because the gradient at a turning point, it's equals to 0. Then I can factorize -3 and x plus 1 equals to 0. and the x value is going to be 3, and the other x value is going to be -1. Already I know that the -1 is there, but I don't know what is the other value here. I'll know that the x value here is going to be 3, but I don't know what the y value is. So how do I get the y value? I substitute into the original equation, which will give me 3 cubed minus 3 into 3 squared minus 9 into 3 minus 5. If I use my calculator, then I'll get -32. So meaning that the coordinates of C are going to be 3 and -32, which I think that will be correct. -32 here, this is -5. So going down there, it can be up to -32. So I know if I got a positive number, then it means that it will be up here and then it will be incorrect. So on the sketch, I'm able to can figure out whether I got this one correct or not. If I got a negative number which is closer to -5, then I know there's something wrong there. So it must be further down for that value to make sense on the sketch. Okay. All right. So interpretation of the graph, quite very easy. Just let's work on the interpretation and we will get these things right. Now the application of calculus, which is optimization, is the last topic that is done in term 1. So the differential calculus, application to calculus, mostly they give you the sketches or they give you an information on the rate of change. So in this case, I've chosen where we get a sketch given in this case. The cone has been given there. It's right cone magnet with the following dimensions. The R is given as that's the radius. We have the L, which is the slant height. We have the H, which is the height of that cone. Express the radius, so express that R. See that thing here, and I know we've done something like this in your pet. That is a right angled triangle. So if it's a right angled triangle, what comes into mind? I've got 3 sides here. What comes into mind? The theorem of Pythagoras. So if they say right, express the radius in terms of its height. Already the slant height is given as 3. So I know that the radius squared plus the height squared will give us the slant height squared. That's the theorem of Pythagoras. Right. So in this case here, remember the slant height here is now your hypotenuse. So in this one, I need the R. Then they said radius. They didn't say radius squared. So radius will be the slant height, which is 9. 3 squared is 9 minus the h squared. And now the R will be the square root of 9 minus h squared. My boys and girls, this R, the square root of 9 minus h squared. It's not 3 minus h. You cannot get the square root of 9 and say it's 3, and then you get the square root of h squared and you say it's h. And you write 9 minus 3. That's very, very, very wrong. In this case, we leave it like that. So that is our radius. So our radius is going to be square root of 9 minus h squared, which is r. Okay. Now, the next question says, show that the volume. In this type of question, you'll be given the formula. Sometimes that formula you must first work it out. You must adapt it to your question. But sometimes you find that that formula is the correct formula. You're going to use it as it is. In this case, you're going to use this formula as it is, because this is the volume of the right cone. The volume for the right cone is third of the area of the base, and that base, which is a circle, multiplied by its perpendicular height. So meaning that, remember, this pi r squared is the area of the circle. So a cone it's a third, that part is a third, the volume, if you want the volume, it's 1/3 of the area of the base. You see the base is a circle here. It looks like an ellipse, but in a cone, if you look at a cone, that cone will be a circle down. So the area of the base, 1/3 of the area of the base, multiplied by the height, which is the perpendicular height. Remember, this one is a slanting height. That's a perpendicular height. So now, they say we must show that. So the answer is already given. We must go to the answer. But I'm going to use that formula. So now I'm going to say the volume is 1/3 area of the base multiplied by the perpendicular height. So it's 1/3, but I know that the r is no longer r. We must change that r because the way the hands means use what we got previously. So it will be 9 minus h squared. You see, I'm not putting a square. Why? It is because the r, it's square root of 9 minus h squared, which means that r squared will be, if I square this, I'll get 9 minus h squared. So that's why in the r squared, I'm not putting a squared up down. So multiply by h. So if I multiply all this, 1/3 multiplied by this will give me 3 pi. All right. This multiplied by that, it's going to give me 1 - 1/3 pi h squared. The whole thing must be multiplied by h. So I'll have 3 pi h minus 1/3 pi h squared times h will give me h cubed. You see, and this is what they're looking for here. So whatever is given there must be the same as what you get when you calculate it. Quite an easy calculations to do. Okay. The last question here is now determine the numerical value of h for which the volume of the cone will be maximum. When I see that word in differential calculus, I then know I must differentiate. So I'll have v, it's equals to, remember now our new one will be, the formula there is 1/3 h cubed. So I'm not going to use the volume of the formula for the volume that was given. So I'm using the one that I got in 10.2. So therefore, I need to differentiate because if I use the other one, it's got an r, and I need the numerical value of h. Remember the r, I've changed it now. It's now square root of 9 minus h. So I'll get dv over dh. So therefore, I'm going to get 3 pi minus, if I multiply this 2, 3 multiplied by 1/3, what do I get? Pi h squared, because I must subtract 1 here on the h. Then remember, this must be equals to 0. So I'll say 3 pi minus pi h squared equals to 0. Then I make h squared the subject of the formula, which will give me minus 3 pi over negative pi. So the h squared will give me positive 3. Therefore, my h will be equals to the square root of 3, which is approximately 1.73. So the value of h now, it's a numerical value. They want the numerical value. The numerical value is 1. So it means that the length of that side there will be 1.73. Then we can get the value of that one. So when it is at its maximum, remember, at the maximum we derive. So we've derived this and then we get to that question. These are easy questions that we must do. You just apply the knowledge of calculus and you are able to can get this question. Let me take this opportunity to really thank you for watching, and please let us practice. Let us go back to our test that we have written and do some remedial on the way for term 1. Thank you.